Alright, the next planet we're going to talk about is Mars. Mars, from a human exploration point of view, is the most interesting planet because Venus is way too hot, nasty clouds, it's just not usable. Mercury has no atmosphere, too hot. Mars is the last terrestrial planet, which means you actually have a nice solid surface. It's a ways away, but we could actually get there. And so Mars is the next step. You know, we've already gone to the moon, so if you want to go next step, Mars is definitely the next step. So let's talk about Mars. Mars has a mass of 0.11 times the mass of the Earth. So it's about 11% the mass. Okay? Remember that the moon was about 1%. Mercury is in the 3 or 4% range, so this is more than that. The diameter is 6,794 kilometers, while the Earth was at, that's the diameter, 12,700. So it's about exactly half the size of Earth, okay, in diameter. Now the density is a little bit lower. It's at 3.9 grams per cubic centimeter. So it's more than the moon, but less than Venus and the Earth. Gravity there is about 0.38, the gravity on the Earth. So you weigh about 40% what you weigh here. Which means it would be an advantage at first when astronauts went to Mars. It would be much easier to walk around with. However, what we find is the human body just adjusts to conditions. So at first it'd be easy, it'd be strong. Maybe, you got to remember you got 6 months to get there. If you're in 6 months in a weightless condition, then you're not going to be ready for Mars anyway. You'd have to do a lot of exercising as well. The rotation period is 24 hours, 40 minutes. So it's just barely longer than the Earth. The tilt is 25 degrees, where ours is 23.5. So there are some very similar characteristics to Mars. Now this is Mars, the way it looks from a telescope on Earth, a good telescope on Earth. That's about as good as it ever gets. And what you see is there's lighter patches, there's some darker patches. This is a polar ice caps, and we can see them on both poles depending on which is winter or summer on Mars. Remember, Mars' year is about 660 days, so it's about 2 years, just under 2 years for Mars to go around once. Now this caused interesting things. Back in the late 1800s, early 1900s, they were studying Mars, and there were people, there were different astronomers that made a lot of claims that weren't really true. Schiaparelli, he was a Frenchman, and then there was guys from Flagstaff too that were looking at Mars, and they said, oh look, a guy named Lowell, Percival Lowell, and he would notice that as you watch Mars over many, many years, that these dark patches would change with the years, with the seasons on Mars. And so he started assuming this was vegetation. And that it was like in the summer when all the trees get leaves, and then in the winter they would go away. And that was what's changing the color of Mars. We know now it has nothing to do with vegetation, but he pretty much had people convinced that there was life on Mars. In fact, they claimed there were people on Mars, and they claimed that there were canals, and the canals would bring moisture from the poles down to feed their crops. And there was all this story, and up until about 1950, even into the 1960s, almost everybody believed that there was actual life on Mars. That's why when they had the War of the Worlds in the 1930s, it was a radio show, and they said the Martians came to attack. A lot of people actually believed it because they believed that there was life on Mars. Okay, nowadays we realize none of that was true, but it took better pictures and exploration to prove that. This is a Hubble picture. So this is as good as you get from the Earth pretty much. But we can see now that it has the polar cap regions. We'll talk more about that. It has darker and lighter regions on it. It has terrain that's not unlike Earth. but it's missing something very important. There's no liquid water. No liquid water on the surface of Mars. All right, let's talk about the atmosphere of Mars. Now, Mars does have an atmosphere, but its atmosphere is mostly carbon dioxide. You'll see it over here. Here's the comparison of Earth's atmosphere. Earth's atmosphere is 78% nitrogen, 21% oxygen. We already talked about that. But Mars is 95% carbon dioxide, about 3% nitrogen, and then a trace of other things. Okay? So, Mars has this huge carbon dioxide atmosphere. Not unusual because we think all the terrestrial planets that have atmospheres, not Mercury, it has no atmosphere, formed with this 95% carbon dioxide. That's the original atmosphere, and it just hasn't changed on Mars. The biggest difference, though, is this. You gotta look at this closely. This 1,013 millibars right here, that's the atmospheric pressure on Earth. On Mars, it's 7.6 millibars. The atmospheric pressure on Mars is so thin, it's thinner than it is even on the highest mountains on the Earth. It is very, very, very thin. Right here, it is about, about 1/800th the pressure of on the Earth has. So the atmosphere is super thin on Mars. If you ever saw the movie Martian, great movie with Matt Damon, but you should watch it. But their premise was wrong. They had this premise that there was this huge storm and all the wind was blowing and it was going to knock over the spaceship. The truth is they do have these giant windstorms that cover Mars. In fact, they cover the whole planet. But the atmosphere is so thin that even with all the air moving very quickly, you could walk right through it. It wouldn't knock you over. Because the atmosphere is so thin, it doesn't have that pressure. It's kind of like when you try to walk across a river that's flowing at 3 or 4 miles an hour, it can knock you down. But wind at 3 or 4 miles an hour, you hardly even notice. It takes a 70-mile-an-hour wind before you start to feel the effects. So even a huge wind on Mars, because the atmosphere is so thin, would not knock a spaceship over. That's not a problem. Now it blows around a lot of sand and dust, and that can cause problems, but it wouldn't knock the spaceship over. All right, so mostly carbon dioxide, but the atmosphere is too thin. You're like, oh, carbon dioxide, this would be a good thing on Mars because it's a greenhouse gas. And that would warm it up, but the atmosphere is so thin, there's not enough carbon dioxide to actually create the greenhouse effect that you need to warm up Mars. So Mars' biggest problem is it's really cold. The average temperature across Mars is on the order of minus 50 degrees even at the equator. Occasionally, summertime on Mars near the equator where it gets the most sunlight can get above freezing and even up to about 40 or 50 degrees, but that's really rare. Most of the whole planet stays frozen, permanently frozen. Water can't exist there. And the atmosphere is too thin. That's why there's no liquid water on Mars. Remember we talked about if you don't have an atmosphere, liquid water can't exist. The water goes from a frozen state right to a gas. So that's one of the challenges with Mars. It can't hold on to a liquid water at this point. All right. So the atmosphere is too thin. Let's look at the surface features. By the way, I have a globe of Mars too, just to show you. And this is what Mars looks like. It's got polar caps on both sides. It has the region, the southern region. Down here is the older region, heavily cratered. And then it has a region of younger region with a bunch of volcanoes. So that's what we're going to talk about right now. All right, so here's pictures. Here's volcanoes. So what kind of volcanoes are these? These are what are called shield volcanoes. Sometimes volcanoes has an E in it. If you're British, you just throw E's in there. Those come from hot spots. Remember we talked about hot spots on the Earth? Hawaii is a hot spot on the Earth, which creates volcanoes. So is Yellowstone Park. It's a hot spot on the Earth. There's several of them. Which means there's magma from below pushing up. Mars has an interesting feature. So if we look at Mars, the surface of Mars, it has a huge region over here. This region is higher than the surrounding. It's kind of pushed up. We call this region the Tharsis Bulge. But it's on the Tharsis Bulge that we see all these volcanoes. There's a number of volcanoes. So what's happening is this region of Mars, this chunk of Mars, has very active, well we think still active, magma that pushed up through it. And it's pushed up a whole region of the crust, and then the places where it pops through creates these shield volcanoes. Now these volcanoes, you can see, here's two different volcanoes. It's kind of interesting because we see impact craters on top, but you see this is the volcano. This is the caldera up here, but this is where lava flowed down into a pool down here. And this was a volcano here too, with impact craters on top of the volcano. Notice that there's not a lot of impact cratering though. There is impact cratering, so this is younger terrain. So this Tharsis Bulge is actually younger. Down here is very heavily cratered region in the southern part. This is the much older terrain down here. Very old terrain. Remember, there's no plate tectonics, so when you have these volcanoes, they don't move like Hawaii where it makes a new island every few million years. Instead, they just keep pushing up in the same spot so you can get really big volcanoes. In fact, here is the biggest volcano in the solar system. This is called Olympus Mons. This is bigger than any volcano on the Earth. In fact, this volcano is so big, this whole volcano is about the size of Arizona, the whole state. So the whole state would be one volcano. Because it's so big, actually if you're on the thing and it sticks way up in the atmosphere, but it's not steep. So you wouldn't even know you're on it because it's hundreds of miles across, so it just kind of gradually goes up and you just get higher and higher and higher until you get up to the highest